Okay, I'm going to start with number 36 for the center of mass. This is on page 26. Now, what we're going to do, we're going to try to find the position of the center of mass when the kid is here with respect to this coordinate plane here or number line. And then we're going to find the new position of the center of mass. I guess I'll call it center of mass prime for the later. And we know that the position of the center of mass should not change because there is no external forces making it change. So basically what's going to happen is that the canoe is actually going to move so that the center of mass stays in the same place in both cases. So for here, I'm going to use this equation here. So I'm going to say, well, the x for the center of mass, in this case, is the mass of the kid, which is 30 times 0. The position is 0 based on this, based on what I did here, okay? Plus the mass of the board, which is, or the canoe, which is 20. Now the canoe is 5 meters long, so the mass of the canoe is kind of like concentrated. It's almost like concentrated in the middle, so that's 2.5 meters away from here, because this whole thing is 5. Over the total mass, which is 50. So now, position of the center of mass in the first case should just be 1 meter. We do the same thing for the second part. Position of the center of mass after the child walks to the other side is going to be the mass of the child. Now, with respect to this position here as the reference, the child is 5 meters away from there, plus 20 times, now this is still in the same place. The board is about 2.5 meters away from this position here. 2.5 over 50. So x, center of mass, after the child walked, over is, so what is that, 150? So it's 4 meters. Okay? So there is a difference of 3 meters between them. So basically the board has to go back 3 meters to basically get back to this position. Because technically you should not have your center of mass move because there are no external forces here, because this is assuming water friction to be negligible. So the difference is just 3 meters. Number 37 in the packet. So you basically have a triangle. Okay. This is 24. It's 10 centimeters here, and it's 26 centimeters here. Put it inside. Okay. And we want to find the center of mass for this object. So I'm going to do it for both the x and the y. Okay. So for the x, for the center of mass equals. Now, I can see that the center of mass of this side here should be right in the middle there. Center of mass of this 26 should be right in the middle. And for this guy, it should be right in the middle. All right. So the x for the coordinate for the center of mass is, well, if you do proportions, I think they're telling us that this thing has a mass of 60 grams, and this perimeter is 60, which means this is 10 grams, 24 grams, and 26 grams. So I'm going to do 24. That's the mass of this object. I'm going to choose this as my 0. Now the coordinates of this guy here are, you do similar triangles, you're going to see that the coordinate of this middle point is 12, 0. For this guy, it's going to be 0, 5. And for the other one, it's 12, 5. So it's 12 here. All you have to do is similar triangles, so you should be able to see that. So it's 24 times 12, the x coordinate of this, plus 10 times 0, plus 12 times 26 times 12. I just want to be consistent. Over a mass of 60 grams. And you notice I didn't change to kilograms because it's all proportional, as long as you keep the top and the bottom in the same units. So this gives me 10 centimeters. If I do the y, Okay, I do 24 times, now the y coordinate of this is 0 plus 10 grams for this vertical side times coordinate 5 plus 26 grams times 5 over 60 again. And that should give us 3 centimeters. So the center of mass has coordinates 3 this way, okay, 310, all right, 310. So is that what it is? No, it's 10, I'm sorry, 10, 3, 10, 3, 10, 3, 10, and 3. So it's about here, okay? And that's it for this video. We'll do more in class. Thank you. I'm gonna do, you have the formula in your packet. I'm gonna write it on the board. We're gonna do maybe 1 or 2 examples and that's it. All right. The position of the center of mass equals M1, that's the object. So let me just write it exactly the way you have it in your formula, in your packet. X1 plus M2, X2. These are positions plus blah, blah, blah over the total mass, which means M1 plus M2 plus M3, etc., right? This applies to the Y component of or the Y coordinate, not component, the Y coordinate, okay? So I'm gonna do which number do I wanna do? I'm gonna do number 16 in the package. It's a redo. So number 16 looks like this. Actually, you know what? Let's do number 16. Let's start with that. So here's the center of mass. This person is 70 kilograms here. This person is 30 kilograms. Okay. And right. So I want to find the position of the center of mass. Meaning, like, because they are balancing around here, so that's your center of mass. That's where you balance it. I'm going to pick this point as 0, right? That's arbitrary. You can choose that. Now, if I want to find the position of the center of mass, what do? I take 70 times the position of the 70, which is 0, plus 30 times the position of the 30, which is 10, divided by the whole mass, which is 100, and that should give you 3 meters. Probably saying, why didn't you tell us the first time? Well, there are multiple ways of doing the same thing. Now let's look at number 17. It's kind of like the same, except now we consider it the weight of the board, so which has a mass of 15 kilograms. Do the same thing. So the x of the center of mass is 70 times 0 plus 15 now. How far is this from the 0? That's 5 because it's smack in the middle. That's only true if you have uniform density. Plus 30 times 10 over, now it's not 100, it's 115. And you should get your 3.26 we did torques. So you can get the same results. Now let's just do 37 quickly.